This is an interesting question where for the first 20 seconds of the journey, we get variable acceleration because v is not only dependent on t, but on t squared. And then after that, we have constant acceleration. So v is kt plus 0.03 t squared. That means the acceleration, which is the rate of change of velocity with respect to time, the instantaneous gradient of the velocity, is going to be k plus 0.06 t. We can now use the fact that when t is 20, the acceleration is 1.3. So 1.3 equals k plus 0.06 times 20. You can put this in your calculator, but we can do it without. If you times by 10, you get 0.6. If you times by 2, you get 1.2. So k is equal to 0.1. Next, we're asked to find the total distance the car has travelled when its speed reaches 25 meters per second. So I'm going to draw a velocity time graph because what we're going to be doing is integrating underneath this to get the displacement, or in this case, the distance. Now, we've got that v is equal to 0.1 t plus 0.03 t squared. We just need to investigate the graph because sometimes they might go below the graph and then if you integrate it, you get like a negative and basically the displacement will decrease, but we actually have to add it onto the distance. In this case, when we factorize out 0.1t, we're going to get 1 plus 0.3t. The roots are going to be at 0, and then the other one is going to be sort of over here. So I don't have to worry about it. In fact, it's going to be a nice kind of quadratic going up like that. Okay, and it would have sort of carried on going down and then gone back up. That doesn't quite look symmetrical, does it? But you know what I mean. I'm focusing on the sketch on the right because that's the key bit. So this is up to 20, and then at that point it just carries on. There's no kink. It doesn't sort of have a kink and go at a different acceleration. It carries on with the same acceleration like that, but it doesn't continue to increase until its speed reaches 25. Okay. So we're going to want to find this blue area, and we've also got this green area to find. Right. Well, let's look first of all at 0 to 20. So at t equals 20, s, the distance or displacement, the same thing in this case, is going to be the integral from 0 to 20 of the velocity. That is going to give 0.05 t squared plus divide by 3, 0.01 t cubed, evaluated between 0 and 20. And we can substitute 0 and you won't get anything, but substitute 20 in. You get 100. Now, to be fair, because this is mechanics paper, and it definitely doesn't show detailed reasoning, we could have just used the integration function. Okay, just use x instead of t, but same idea. And this is the thing that we haven't yet integrated. It's very important. And then put in 0. It's also a little check if you did do it by hand. And we get 100 that way as well. So I've shown my working. So we know that this blue area is 100. Right, now for the green area. So I'm going to apply suvat for this actually, because it's constant acceleration. What we need to do, first of all, is find the initial velocity at that point. So I'm now looking, I'm still actually looking at 0 to 20, and I can, at t equals 20, we can also find what v is. So it's going to be 0.1 times 20 plus 0.03 times 20 squared. So yeah, put it in. We're going 14 meters per second. Therefore, let's look at 20 onwards. So t is going to be greater. We don't know what time we're actually going to. We only know that we're going to stop the time when v is equal to 25. We're not, in fact, interested in the time here. You could work it out, and then actually you could work out the area of the trapezium, but we can avoid doing this, in fact. So this is where suvat kicks in, because it is now constant acceleration of 1.3 that we had from before. The initial velocity is 14. Final velocity, as we were told, is 25, and that's all we need. Okay, we don't need the time. So v squared equals u squared plus 2as, the one not involving time. 25 squared is 14 squared plus 2.6s. Which gives 165. And that is this area here. So we're asked the total distance is going to be 100 for the 0 to 20 part. You have to split into these two parts, plus 165 for the second part with suvat. Therefore, 265 meters.